All right, volume of a sphere. Hope you can hear me and see this. I'm back in the classroom today. Had to clean it up for the end of the year, so I thought I'd do a video while I'm here. Volume of the sphere. Last lesson of the week. All right, there's the formula. I'm just giving it to you right off the bat. And you look at that, and it may not make any sense to you. It doesn't look like it has a lot of rhyme or reason. 4/3. Who came up with 4/3? And then r to the third power. Why are we cubing the radius? So I'm going to try and explain to you where this formula comes from. All right, I've been telling you all week to think of these problems as area of the base times the height. Well, what is the base of a sphere? All right, there really doesn't seem to be one. So to get one, we're going to cut the sphere in half. All right, exactly in half. So we're going to have what looks like the base of a cylinder or a cone, but it's actually going to be half a sphere. So there's half my sphere, the top half of the sphere. Now we can do area of the base times the height. The base is a circle. Area of the base is pi r squared. And the height is actually another radius because it's a sphere. So just like a circle, it doesn't matter what direction you go when you draw a line from the center to the edge of the circle, it's a radius. Same with a sphere. It doesn't matter if I draw my radius going across like this or if I draw it straight up, it's going to be the same length. So it's really pi r squared, area of the base, I'll say that's area of base, and height is another radius. So it's pi r squared, area of the base, times the height. Pi r squared times radius, which is pi r to the third power. So there's where r to the third power comes. That third r is really the height. Okay, now where does the 4/3 come from? This one's pretty cool too. This one starts off with a cylinder. So let me draw a cylinder that's supposed to be the same size as my sphere here. That's a horrible, horrible cylinder. Sorry about that. All right, let's say that this cylinder is has a radius of 6 and a height of 6. So we'll say that this half of a sphere was the same. It had a radius of 6 and obviously the height of 6 because it's also a radius. I just explained that. So if you have this situation where your cylinder and your half of your sphere, basically the half of the sphere would fit perfectly right inside this cylinder where it would touch the top of the cylinder right at the top, right in the middle. All right, that fits right in there. And when you do that, this half a sphere takes up 2/3 of the space of that cylinder. All right, similarly, what we did yesterday was a cone. If you have a cone that's 6 by 6, it would take up 1/3 of the space of that cylinder, right? Because the volume of a cone is 1/3 pi r squared times h. So a lot of teachers or some teachers will actually get containers that are the same dimensions. A container that's like a bowl, half of a sphere, a container that's like a can, a cylinder, and a container that's like a sugar cone, an ice cream cone. And they'll all have the same dimensions. They'll all have the same radius and the same height. And they'll pour water into the bowl, the half sphere, and pour water into the cone, and then take those two objects and dump them into the cylinder, and it exactly fills up the cylinder to the tippy top. The cone plus the sphere is the same size as the cylinder. The sphere, half a sphere, is 2/3, and the cone is 1/3. So 2/3 plus 1/3 equals a whole. The 2/3 plus the 1/3 equal the size of the cylinder. So this is where the 4/3 comes from. 2/3 is half the sphere, and if we want the other half of the sphere, the bottom part, ooh, wow, my art has gotten worse since the break. That egg-looking disaster is supposed to be a whole sphere there. So if we add on the bottom of the sphere that I cut off, that's another 2/3. 2/3 for the top, 2/3 plus the bottom. that equals 4/3. So that's where this formula comes from. 4/3 of a cylinder times pi r squared base times height, which is another radius, radius to the third power. All right, there's your lesson on where the formula comes from. Now, the problems in the homework and in future tests aren't going to ask you if you know where to derive that formula from. They're just going to want you to apply it to a sphere. So it'll be simple problems like, here is a sphere, and what is the volume of that sphere if, say, the radius is 4 inches? Well, it's 4/3 pi times radius to the third power, 4 to the third power. 4 to the third power is 64. So it's 4/3 pi times 64. I'm just going to move that pi to the end so it's kind of out of the way there. So it's 4/3 times 64, and when you multiply a fraction times a whole number, it's the numerator times the whole number, because remember, that's like over 1. So 4 times 64 is 256, so you get 256 thirds times pi inches cubed. That would be your volume for that one using this formula, and that's all there is to it. Once you have the formula, you just plug in the radius. That's the only number you have to plug in, and the math isn't too difficult as long as you remember how to multiply a fraction times a whole number. So just be careful on the problems. If they give you the diameter to start with, if they would have given you something like this and said the diameter is 8, then don't plug in an 8 here, you plug in the radius. Radius is half the diameter. So make sure you're plugging in the radius and not some diameter or some other number that they give you, and you should do fine on these problems.